Alright, in this video I'll be solving a Math 2B midterm given in winter 2018, midterm 2. Okay, this is given by the same professor for the video I did of the midterm 2 given in fall 2017. Okay, so I took a look at some of the problems in this midterm. Some of them are the same as the others, so I'll just refer you to the other video if it's the same problem. Okay, so let's begin. So for example, this first problem, cosine to the fifth x, sine to the fourth x, dx. I solved it in the other video, so go look at that. 1b, this one is new. We have ln of x quantity squared dx. Okay. So how do we solve this? This one, let me see our techniques. Can we make a substitution? That probably will not work if u is ln x. du will be 1 over x dx. There's nothing like that. It's not trig integral, not trig sub, not partial fraction, so it's probably integration by parts. Okay, so what happens if we let, this might not be correct, I didn't look at how the key did it. What if we let u be ln of x squared? What if we do that? Du would be 2 ln of x to the first power times derivative of ln x, which is 1 over x, so that would be du, and then don't forget your dx. dv will be just be whatever's left, v is equal to x. Okay, that looks like it can work. Remember, integration by parts is uv minus v du, so x ln of x quantity squared minus the integral v du. So that's just, the x's would cancel, the 2 we can move out to the front, ln x dx. Okay. This integral we know how to do. That's also integration by parts. So let's do integration by parts one more time. Du would be 1 over x dx. dv would just be dx. v is equal to x. So we get x ln of x quantity squared minus 2 times, this would be x ln x minus integral dx, because this guy, the x's would, x and 1 over x would cancel. Okay, this is easy. Minus, let's distribute to 2, 2x ln x plus 2x, because the integral of dx is just x, and then we have the 2 plus c. And that should be your answer, and let me check that I'm correct. That's correct, so you could do it like this. The key actually did it a more complicated way. I don't know why they did it like that. But anyway, this is the answer for 1b. Okay, let's move on. 1c, let's hope I can fit it on this page. We have integral of 1 over square root of x squared plus 4 dx. The hint is square root of something squared plus something squared, probably trig sub. So we set up a triangle. We know that by the Pythagorean theorem, because it's something squared plus something squared, this square root term is the hypotenuse. Okay? And we have x as one of the sides and 2 as the other side. So you can set up your triangle like this. We know that, okay, so we want to substitute everything in this integrand in terms of theta. We know that tangent theta is x over 2, so 2 tangent theta is equal to x. We can get dx now because we need that. 2 secant squared theta d theta is dx. And we can sub the square root term also. That's square root of x squared plus 4 is equal to, well, we know that secant theta is this over 2. So 2 secant theta is the square root. Okay, so we can substitute everything in this integrand in terms of theta. dx, remember, is over here. 2 secant squared theta d theta. The square root term is just 2 secant theta. Okay, so we have the integral of secant theta d theta. Remember how to solve this? If you memorized it, it's just ln a secant theta plus tangent theta plus c. Okay, this one you should just memorize. Okay, let's back substitute secant theta and tangent theta. We have both the terms here, so we can just say it's ln of secant theta is square root of x squared plus 4 over 2 plus tangent theta is just x over 2 plus c. That's our answer right there. Okay, so that's that problem, pretty easy. Let's move on. And then we have 1D, which is the integral of x plus 5 over x squared minus 5x plus 4 dx. This one looks like it's partial fractions, so we can write this as x plus 5 over, if we factor the bottom, it will be x minus 4, x minus 1 is equal to partial fraction over a over x minus 4 plus b over x minus 1. I believe I solved this in the other video. Let me double check that that's the case. Oh, I solved a similar problem with the same denominator. Okay, so let me do this one. Okay, so that's the partial fractions. So we multiply both sides by the denominator, this denominator. That'll be x plus 5 equal to a, x minus 1 plus b, x minus 4. Okay, if we plug in x is equal to 1, this guy would go away. We get minus 3b is equal to 6, or b is equal to minus 2. If x is equal to 4, then this guy would go away. We get 3a is equal to 6, so a is equal to 2. Okay? Is this correct? Let me see. X is equal to 1, 6. Sorry. This would be 9. Okay? And then this guy would be, because when we plug x is equal to 4, this guy would go away, this would be 3a, this would be 9, so sorry about that. So a is equal to 3 actually. Okay, so we can rewrite this integral as the partial fractions, 3 over x minus 4 minus 2 over x minus 1 by dx. Okay, we plug in a and b. Okay, this is easy to solve, it's just logs. 3 natural log x minus 4 minus 2 natural log x minus 1 plus c. That should be your answer. Okay. Number 2, we're moving on to improper integrals. We have to say if it converges or diverges and what it converges to, or if it diverges to minus infinity, plus infinity, or neither. Okay, so we have the integral from 0 to infinity, 3 over x squared plus 4 dx. So this is improper because it's going to infinity. Okay, so how do we solve this? Here we know we can, there's multiple ways that you can do this actually. You can maybe even do partial fractions, I don't know. You could do trig sub, that could work. However, I do recognize this to be arctan already. So how did I know that? Well, this would be, we factor out the 3 dx over x squared plus 4 from 0 to infinity. Okay, we can rewrite this as 3 integral from 0 to infinity dx over, if we factor out the 4, it will be x squared over 4 plus 1. Okay, And we can rewrite this as 3 over 4 integral from 0 to infinity. We moved out 4 from the integral dx over, we can rewrite this term as x over 2 squared plus 1. This looks more like arctan, right? If we let u be x over 2, du would be half dx. Okay? So we get 6 over 4 integral from 0. Actually, is our limits of integration still 0 to infinity? If x is equal to 2, u is 0 over 2, which is 0, that's fine. When x is equal to infinity, u is infinity over 2, that's still infinity, so that's fine. The limits of integration happen to be the same. Okay, we get, this would have been 2 du, I already pulled the 2 to the front, so du over u squared plus 1. This you should now know as arctan, so we can simplify 3 over 2. Arctan of u, evaluate this from 0 to infinity. We can rewrite this as 3 over 2 limit, this is the proper notation, t goes to infinity, of arctan of u from 0 to t. Okay, so we would get 3 over 2 limit t goes to infinity. We do fundamental theorem of calculus. Arctan t minus arctan 0. Let me shift like that. Arctan t minus arctan 0, that's fundamental theorem of calculus. Arctan 0 is just 0. So we got this. Remember how the arctan looks? Looks like this. It has an asymptote as it goes to infinity. What's the asymptote? It is 3 over 2 times, the limit would be pi over 2. Okay, so that would just be 3 pi over 4. So this improper integral converges to 3 pi over 4. Okay, not too bad. This one you just had to recognize that was a arctan. Again, you could do trig sub, that will for sure work. Partial fractions might work also, I'm not sure for that, but as you see, there are multiple ways to solve it. Okay. Whoops, this is looking messy. Doesn't rip well. Okay, let's move on. 2b, we have integral from 2 to 4, 1 over square root x minus 2 dx. Okay, this is improper because as we approach 2, here, this guy would go to 0. Okay, so we technically rewrite this as limit as t approaches 2 from the, is it from the right or from the left? This one is the lower bound, which is to the right. That's limit as t goes to 4, t to 4, 1 over square root x minus 2 dx. This integral, you can do a substitution. If you know how to do it in your head, great. I'm going to do it in my head. Okay. There should be 2 square root of x minus 2. Because if you differentiate this, it'll be 2 over 2 square root x minus 2. So those 2's will cancel out. Yes. Okay. From t to 4. Okay. So we have limit as t approaches to 2 from the right. We can factor out the 2, move the 2 out to the front. That'll be square root of 4 minus 2 minus square root of t minus 2. Okay, this limit is just, you can rewrite this as 2 times 2 minus 2 times limit as t goes to 2 from the right, square root of t minus 2. Okay? This guy is easy. This limit goes to 0. So it's 2 times 0 is 0. Right? So then we get, I got 4, but they got 2 root 2. Oh, sorry, this is root 2. Because this guy is not square root of 4. This is square root of 4 minus 2, which is square root of 2. Okay, so we get 2 root 2. So a small algebra problem there, but everything else was correct. Okay, so it converges to 2 root 2. Okay. Next, we're asked to find if the sequence converges or not, and if it does converge, what does it converge to? If it diverges to negative infinity, positive infinity, or neither. Okay. So the first sequence is this. Okay. If you recognize this, this should look very familiar. Something to do with like compound interest, if you remember that, or it should look like E, something like that also. Okay, that's just a big hint if you recognize that. Okay, well, okay, so how do we find if this converges? It's the limit as n goes to infinity of the sequence. Okay, so how do we find that? Well, we can, okay, this one, because it's something of n to the n power, we can use the technique where we log it. Natural log of a sub n, this guy, is equal to natural log of 1 plus 1 over n squared to the n power. So natural log of a sub n, remember properties of logs, we can move it out, the exponent out. Okay, so let's take the limit as n goes to infinity of natural log of a sub n. So that's limit as n goes to infinity of n times ln of 1 plus 1 over n squared. Okay, so we can rewrite this as limit as n goes to infinity, natural log of 1 plus 1 over n squared over 1 over n. That would work, right? This would be 0 over 0, so that is indeterminate, so we're on the right track. We can use L'Hopital's rule. It's 0 because this guy would go to 0, so ln of 1 is 0, this guy would go to 0, okay? This guy, we take the derivative of the top and the bottom. So the bottom would be just minus 1 over n squared, that's easy. How about the top? It'll be 1 over 1 plus 1 over n squared times derivative inside, that would be derivative of 1 is 0, derivative of n to the minus 2 would be minus 2n to the minus 3. Okay, so let's clean this up. Limit n goes to infinity of, so this guy, we can get rid of the sign, that's easy. Okay, so this guy is the same thing as, so 1 over 1 plus 1 over n squared, we have that on the top. We have 2 over n cubed, that's this term. This 1 over n squared on the bottom is just the same thing as n squared. Okay? We keep going. Can I fit this on this page? Limit n goes to infinity of, we can cancel some things here. This and this would cancel, so we're just left with the n, so it'll be 2 over n, that's what we're left over here, times, let's rewrite this a little bit. It can be, if we multiply n squared on the top and the bottom, it'll be n squared over n squared plus 1. Okay? This now is easy because, well, let's do one more step. 2n squared, we combine, it'll be n cubed plus n. Here, as we take the limit as n goes to infinity, remember that's a horizontal asymptote. Degree, we can do the degree test. Degree of the top is less than degree of the bottom. So we know that this goes to 0. Okay? We're not done yet. That was limit as n goes to infinity of ln of a sub n. So we have to exponentiate both sides. So this guy is equal to e to the 0, which is equal to 1. So this guy converges to 1. That's the technique to solve this guy. That's 3a, by the way. Okay? So notice how I said this guy looks like e? Yeah, that's the reason why. Okay? Let's continue. I'm not able to change. Okay, there we go. This is not ripping well at all. Okay. moving along. Okay. 3b, we have a sub n is equal to 1 over some big term over here, n square root of n squared plus 2 minus square root of n squared plus 3. Okay, so how do we find if the sequence converges? Limit as n goes to infinity of a sub n. That's easy. So how do we find the limit as this guy goes to, as n goes to infinity for this guy? Okay. Remember when he has some square root, we like to use conjugates to try to get rid of it. So let's try that. Limit n goes to infinity, 1 over n times square root of n squared plus 2 minus square root of n squared plus 3. So let's multiply the top and bottom by the conjugate of this, which is square root of n squared plus 2 plus square root of n squared plus 3 over, the bottom's the same thing, square root of n squared plus 2 plus square root of n squared plus 3. When we do that, limit as n goes to infinity, let's leave the 1 over n there. So then we get square root of n squared plus 2 plus square root of n squared plus 3 over the bottom. If we FOIL it, this guy would be n squared plus 2. This is plus, this plus minus, those would cancel, so minus parentheses n squared plus 3. We get this. Okay. So we know that this n squared and this n squared would cancel because of that minus sign. So at the bottom we are left with minus 1. So let's factor that out. Limit as n goes to infinity of, so if we clean it up, we get n squared plus 2 plus square root n squared plus 3 over n times another 2. So we can, actually not 2, because 2 minus 3 is minus 1, which we factored out already. Okay. Okay, so we have this limit. How do we solve this? Remember the technique? We like things 1 over n or 1 over n squared. We like things like that, because when n goes to infinity, the thing goes to 0. So limit as n goes to infinity with a minus sign in front. Okay. So we can factor out n squared, so that'll be 1 plus 2 over n squared, plus, again, factor out n squared, that'll be 1 plus 3 over n squared, all over n. Okay? Because n is going to infinity, square root of n squared is positive n. So this is the same. We get n times, we get n here, we get n here, we can factor that out. So square root of 1 plus 2 over n squared plus square root of 1 plus 3 over n squared divided by n. Okay, we get this. Now these would cancel. As n goes to infinity, this would go to 0. As n goes to infinity, that would go to 0. So we would get minus limit as n goes to infinity of, we're left with square root 1 plus square root 1, which is minus 2. Okay, so the sequence up here converges to minus 2. Okay, that was a lot of work, but it converges. Okay. And then we have 2 more, so let's move on. (3c) we have a sub n is 2 plus cosine of n over square root of n. Does this converge or diverge? Okay, so here we can use the squeeze theorem, because L'Hopital's rule I don't think will help us, because cosine as n goes to infinity, cosine infinity, you don't know if it's plus 1 or minus 1, okay? So let's try to squeeze theorem. We know that cosine of n, cosine is always between minus 1 and 1. Okay, so if we add 2 everywhere, that would be 1 is less than or equal to 2 plus cosine of n, which is less than or equal to 3. I added 2 everywhere in this inequality. And then we multiply by 1 over square root n, we get 1 over square root n, less than or equal to 2 plus cosine of n over square root of n, which is less than or equal to 3 over square root n. Okay? We know that limit as n goes to infinity of 1 over square root of n, that's simple, that's 0. And we know limit as n goes to infinity of 3 over square root of n, that's also easy, that's 0. So therefore, limit as n goes to infinity of a sub n is also 0 by squeeze theorem. You should write squeeze theorem. So it converges to 0. Okay, final problem, 3D. We have a sub n is minus 1 to the n over n cubed plus 1. We can use the fact that we can do limit as n goes to infinity of absolute value of a n. We can find that first. And that would just be limit as n goes to infinity. When we take the absolute value, this minus 1 to n would go away because that's just changing the sign, plus 2 and minus 1. This is 1 over n cubed plus 1. This is easy. This would go to 0. Okay, so because this guy goes to 0, we know that limit as n goes to infinity of a sub n is also 0. So it converges to 0 also. Okay, that was this midterm. Honestly, it was not too bad. The only tricky one was, the integrals were all super easy. The only tricky one was this one, and maybe even this one over here. This one was tedious. Okay, but otherwise it was pretty straightforward. And yeah, and obviously I did like the first problem on this first problem on a different video, so that saved me time also, but go check that video out to see how to solve that. So yeah, that's the end of this video. If you have any questions, feel free to leave it in the comments. Otherwise, please hit that like button if this video helped you, and please subscribe to see more videos like this.